The broadcast is now starting. All attendees are in listen-only mode.
All right, good morning to everyone. This is the 11 a.m. Webinar for What's New Features within TopSolid'Cam. In this webinar, we are going to cover improvements to the 2D milling section of the software. I see some other people are still logging in, so I'm going to give it just maybe 10 more seconds or so, and we'll get started off. So while people are logging in, I'm going to load up the first one. So the first thing we're going to talk about is a new feature in TopSolid that allows you to do broaching. All right, I think everyone's in, so let's get started. So broaching is a new command inside of TopSolid 7. There is a couple of different ways to use it, and I'm going to try my best to kind of show you all of them. So let's, just going to delete my toolpath here and we'll start from scratch. So I'm going to go ahead and just select a face. I can right click, under others, I can go to broaching. Once we go to broaching, of course, we need to pick a tool. I already have a broach defined, so I'll go ahead and load that up. And then we need to go into our geometry and we need to choose a lead direction. So this is the direction that the broach is going to be machining in. Now, when you're machining with a broach, a couple things you need to take into consideration is under cutting conditions, you have to choose what you want or which driven point you want to drive by. So in this case, for example, I just switched to the middle front edge. Of course, you can drive by the bottom of the tool if you want. You can drive by a left point, a right point. It's up to you on how you want to drive this. There are some requirements for tool definitions on this as well. And if there's some time, I'll show you guys those requirements also. Basically, it's just a new tool definition. So you just need to learn how to define the tool. Now, from there, let's just click OK and let's see what it does. So you can see it indexed the part. It's going to position up. Let's slow this down a little bit. And it's just going to start doing what a broach does. So you can see it's nice and simple. Now, from here, let's say, for example, that we want to extend the over length here. So we can say, go to 5 millimeters, go to 5 millimeters past if you want. Now you can see that we're getting out here. Maybe we want to go 6 millimeters past there. Perfect. As far as machining the rest of the features in here, let's go to geometry and we'll just do a simple repetition. Okay, so I'm going to go to pattern here, circular pattern. About the center of that, I'm going to set the starting feature to be right on that corner, just so I can make sure I have the right number of instances, which I do. Perfect. And now we're going to see all of them. Now, the last thing we'll talk about here is how we're dealing with the positioning of these. So you can either rotate the part or you can rotate the tool, and I'll show you both. So if we do rotate the part, and we simulate, so we're going to see that come in, do its thing. And then it just rotated the part. So we're keeping the same tool orientation throughout the entire process. Now, perhaps your machine supports rotating the tool or indexing your tool. If it does, you can use rotate the tool instead, in which case the C-axis on this machine anyways would be blocked. And now we will index the tool. So let's watch what that does. Okay, there's the final pass on that one. And now we should index. So now the tool rotated and we're on to the next feature. Index and done. Special post commands required? No, I don't believe so. It's a feature, it's set to the PDB, so it'll post process just fine. Okay, that's broaching. There's nothing really that complicated about it. It just now is a cycle that you have full control over. Alrighty, let's move on. So let's see. For those of you that are using boost milling, there's a couple of improvements this year on boost milling. So let's have a look. So this first one is a specific coolant. Hold on, I'm just updating my notes here. Specific coolant type for the plunge. So if we go into this pocketing, and we first of all, let's go look at our cutting conditions, and we have an air blast or something turned on. So we have one form of coolant there. And then if we go to boost, or plunge, excuse me, you can see down here, I've activated custom coolant. It's set to center, or set to whatever type of coolant you want. And if we go to generate the ISO code for this, so first coolant type, plunge coolant type, back to standard coolant type. Okay, so that's that. Let's keep on going. Excuse me. We've also made it possible now within boost milling to have contouring integrated into it as well. Okay, so this is available in the end milling version of boost milling. So if we go look in here, a couple things to understand about this. To use it, it's simple. In your settings, you just activate contouring. But when you do that, the high-speed machining loop radius is not 100% used. What do I mean? Because you're contouring here, and like in this sample, I don't have a corner fillet in that corner. Let me turn this tool off for a second. You can see boost has to continually work its way into the corner so that you can do your final pass. If I turn off contouring integrated, the high-speed machine loop radius is taken into consideration, and of course we add a small radius in that corner because there is none there, or because the tool is larger than the corner radius that is there. Okay, so just an important distinction to understand about if you're going to use integrated contouring. Beyond that, when you're using integrated contouring, you have access to all the things you're used to with integrated contouring. Cutter compensation, is it used, is it not used, what's the final depth of pass that you want to take here as well, and that's it. Alrighty, next improvement. Okay, hold on one second. I see a question pop up. How does it finish the floor with contouring integrated? So if we go back to this, it depends on what you set the operation to. So if I go back into this operation, so this is doing boost to 0, because again, it's just a demonstration. Likely, unless it's not a high tolerance part, you're probably roughing first and coming back and finishing second anyway. If you are roughing and going straight to finishing, we go into settings here. And if you're taking multiple axial depths, maybe it's a deeper pocket, you have the ability to activate contour last path only. So if we go here and let's say we set this to 10. Okay, 5. What am I on here? Hold on. Axial depth. There we go. So now you can see we have 2 depth of cuts here. So at each depth of cut, contouring integrated, or we activate this option, which means at the last depth of cut only are we going to integrate this. Okay. Does boost milling lift up like volume mill? It does have micro lifts if you decide to use them. And volume mill had micro lifts if you decide to use them as well. But you can set the lift to be 0 if you want. Okay, so next thing about boost milling is the climb and conventional mode is now fully supported. What does that mean? So we've added the ability to, and this is in the end milling use of it, roughing use of it, and 4-axis radial roughing use of boost. We've added the ability to do both climb and conventional passes. Okay, and I'm going to show you the difference here. So we have the use mixed milling direction. If I turn that off, okay, this is your reposition clearance. One of you was just asking if it lifts. This is that micro lift right here. So here, you can see the micro lift. Okay, it's a kind of a helical lift up and a helical drop down. Okay, if we do it this way, and let me change this to be maybe 20%, so it's a little bit bigger, even 25. This way we can see things a little bit more clearly. So if we do this and we run the simulation on this, so nibbling, rapiding over, again, it's max feed rapid, but we're rapiding over, so we're cutting nothing on the back end of the movement here, okay? If the material you have allows for both climb and conventional machining, now we can take a look. Let's go turn that on. And now you're gonna see that it just sweeps back and forth with really nice high-speed turnarounds. So now we can watch that simulation. And now we're climb conventionally, or climb and conventional machining. And there's those nice little loop turnarounds. Alrighty. Let's keep on going. Boost mill smoothing. So this is a new feature. This is available everywhere Boost is available, in end milling, in roughing, in 4-axis radial roughing. You now have the ability to smooth the tool path. Okay, the smoothing of the tool path makes it possible not to be parallel to the part. Currently, this is unsmoothed, and you can see that the tool path is relatively parallel to the part, and in these corners, it's nibbling into the corners to help keep things moving, okay? If we go into this operation, and the reason why you might do this would be the goal is to reduce the abrupt changes of direction by opening the material with larger loops and reducing variations in the feed rate, okay? So if we look here, currently, you can see what the non-smooth boost milling toolpath is doing. It's still very good, clean toolpath. But if we go into settings and we go to boost, now you see a smoothing bar. Okay, and you have 5 values here. So if I go all the way up, watch what happens. Now we switch to concentric circles to make big sweeping movements, and you have less turnarounds. Okay, you can back this off a little bit, and you can play with how much smoothing you want. So here you can see big sweeping movements, okay? Then we get into here where we have more linear, back to big sweeping, into linear, and so on. So smoothing puts you, it gives you a little bit more control over how you may want the motion of the machine. And why this could be important, maybe on a big part, it's not so big or big of a deal, but on a little part where you have lots of turnarounds and direction changes and everything, smoothing this would make for smoother motion on the machine. It's easier on the machine. Alrighty. Let's keep on going. All right, so toolpath optimization. Okie dokie, so right now what we're seeing here is the results of boost mill from 7.14. Okay, this is the way it was, and I'm going to bring this over so you can see. In 7.14, the way the order of toolpath was is we did this entire center, then we did this, rapided back over, did this, rapided back over, did this. Once this side was done, then we came to this side and did this side. Okay, if we go and simulate this, let me get this to the end. All right, so we're nearly at the end here. And then what you're going to see is we cut that side and we wrap it over. We cut that side, again, max feed over, and then we're cutting this side. So we're wasting a lot of time in unnecessary motion. So let's go upgrade this. Just as a reminder, if you have legacy files, you come here to upgrade once you come to 7.15 to get the latest algorithms. And then we can go ahead and execute. And you should be able to see right in the toolpath the differences already right here. So you can see that we're just going straight across. Okay, so let's go ahead and watch the simulation. Let's get this back up to here. And now walk straight across, just so we keep the tool in cut longer, basically. Getting rid of unnecessary movements. Okie doke. Next. So boost milling toolpath on open area. So this is available in end milling, roughing, 4-axis radial roughing, anywhere the boost algorithm is used, in fact. In 7.14, the toolpath turned around the edge of an open pocket. And in 7.15, we've straightened it out. So if we look at this, here's your boost milling. And you can see the open pocket, see how it's kind of rolling around that edge? So if we go here and we unfreeze this, and we go up to here and we, pardon me, to edit, and we upgrade, then we can execute this. And now you see how it squares it off. Okay. Alrighty. So now let's keep going. All right, next, for those of you not aware, boost milling is officially replacing volume mill within TopSolid. So if you have volume mill licenses, when you receive your 7.15 licenses, they will automatically be updated to boost milling licenses. Now, what does this mean for you? When you import a package or you open a package for the first time in 7.15, you're going to get this message. And the message just basically says volume milled strategy isn't available anymore. Corresponding operations have been switched to boost strategy. Please check the operations manager to see these modifications. Do you wish to freeze the corresponding operations to keep the previous volume mill path? So what we're allowing you to do is if you're just opening this because you need to push process again, you need to make a few minor changes, you can choose yes to this, and the volume mill toolpath will come in frozen. It means if you regenerate the file, that specific toolpath will not regenerate. If you unfreeze it and regenerate, then it will, of course, update to boost, and then you'll want to check those operations to make sure, since the algorithms are slightly different. Okay? All right. Plunge. Let's talk about Plunge. So this has to do with pocket plunging, side plunging, punching pocketing. We've added a new parameter to optimize the depth of each plunge. So if we go take a look at this operation, go into our settings here once it loads up. Okay, and then we go into our altitudes. Here you see the new parameter. It's called optimized depths. And what this is looking at is if we look in here, and let's see if I turn off my toolpath preview. There we go. And apparently my stock is not active, so let's go activate my stock down here. Let's turn this off for the moment. Sorry. So I'm going to roll this back so you can see the stock. So you can see the stock, the center was drilled out with a big drill already. So there's some material here, right? And this cross hole has been drilled already. So being that the cross hole is drilled, there isn't as much material here at the peak relative to the tool axis as there is over here. So with that said, if we go look at this new option, we go into our settings and we go to altitudes. If I turn this off, you'll see the difference right here on the left side of the toolpath, because now it's drilling unnecessarily, right? Or to depths that are not necessary. If we activate this, it's really, really paying attention to the updated stock model. Okay. Perfect. Okie doke. So, end milling optimization starting altitude. So, in 7.14 and versions before, if you're finishing the floor of a pocket, you kind of had to fight to get the helix to start at the correct altitude sometimes. In 7.15, you no longer have to fight with the software. Now it pays attention properly that there is only so much material on the floor, so much material on the walls, so it auto adjusts your starting altitude for you. Alrighty. Yes, I agree. That's a great improvement. Some of these are just functional improvements, natural evolutions. Some are new, obviously. So, end milling, side milling, multi-geometry. This is awesome. This might be one of my favorite improvements for the 2D milling. What you're looking at here is one end milling with multiple different altitudes selected and the tool path fully optimized to what's going on. What do I mean? Let's go look. If I go into my geometry, you can see I've selected these three faces. Okay, and let's tell you what, let's just delete them all so that you can see what's happening. Okay, here we'll start from scratch even. So I'm gonna go here, go to end milling, like you normally would. And maybe my depth of cut here, maybe I want it to be fine, 1/16 of an inch. Cool. Now, I also want to machine this altitude. But at that altitude, I'm not too concerned about taking a shallow depth of cut necessarily, so maybe I'll do this every 150 thousandths. Okay? And what you're seeing, if we zoom way up on the tool path here, is my slots were extended to the stock at that altitude, but now for this face, it is being trimmed up because the slots have already been machined. Let's go ahead and look at verify, because it will be the easiest to see it there. All right, so let's get in here. So you can see that extended it out to there, and let's maybe do it this way. So that extended out that tool path out to the edge of the stocks like it normally would. Okay, and I'm going to slow this down now because now we're going to get to the other one. And now we're going to nibble. And you notice where it's plunging here? It's plunging in air because it knows the stock is update there. In 7.14 and earlier, you had to treat these as separate machining operations in order to get that optimized motion. In 7.15 now, we're paying attention to the order that geometry is selected in a given operation to fully optimize that tool path. Okay? The other thing that's nice about this is the fact that you can control different depth of cuts at different altitudes even. So again, at those slots, I'm doing shallow depth of cuts. Let me look at this straight on for you. So you can see I'm doing shallow depth of cuts there, and then I'm doing deeper depth of cuts everywhere else. And again, you can have as many altitudes here as you want. So I could add a third altitude down here. Why not? This improvement, by the way, works on end milling and on side milling. All right. Okay, perfect. All right, next one. This one's actually kind of cool too. So this has to do with authorizing plunging on an end milling operation. Okay. Go here. So I'm going to go ahead and select all of my faces that I want to machine. Then I'm going to go to end milling. Right now, it's doing everything, but maybe you don't want it to plunge, or maybe the tool can't plunge, right? So if we go into here and we go to settings and we go to our plunge, you can deactivate plunge authorized. And now you get a warning message, and I'll show you that in a second. Anywhere the tool would have plunged on material, even with the helix or ramp or whatever, it is automatically not creating that tool path. Okay, and this gives you that message saying plunge prohibited in material, plunge authorized in full material is disabled. Okay, for those of you who don't keep your event manager open, I recommend keeping your event manager open. We have event information there for a reason. So, please be sure to take a look at those things. A couple things about this new command. Let me drag this over. So obviously, if it's unchecked, grays out the area. Okay, I told you it brings in the little message there. There's two cases that we manage. So if the tool can cut in the center, it's a center cutting tool, we can enter by helix or direct without problem and without warning. Okay, that's if you have activated the plunge authorized. Case two, if the tool does not or is not a center cutting tool, it'll still allow you to plunge with plunge active, but it will give you a warning telling you to run direct plunge allowed with the tool without center cutting. Okay, so it's just reminding you that, hey, this is a non-center cutting tool and you're plunging with it. Okay, perfect. All right, let's move on to the next thing. Okay, so we kind of talked about this up here, or in boost milling, but basically if we unfreeze these operations, these were created in 7.14, right? And I believe I can just regenerate. Nope, I need to update. So upgrade, now regenerate, and now you're gonna see we're coming off straight. Because there's a radius here, we're coming off that way. Because it's a straight line here, we're coming off exactly tangent that way and that way. Okay. I believe you guys are asking about orders on the other. Here. Where is my multi-geometry? Yes, I should have pointed this out. So if I go to geometry, and for example, I say I want to take this bottom face, move it up, okay? Where are we at? Well, here, make it easier. I want to machine this face first, then this face, then this face. Okay, and you can see it's optimizing accordingly. So if you order them or you go from the bottom widest feature first, then to the next one, then to the next one, it of course is paying attention to the stock. Is that what you guys were looking for? Sure, why not? You have full control over the depth of cut. And again, add boost to it as well, why not? And then you're really making optimized motion on a part like that. Okay, we did straight line. Let's go number of axial passes. Okay, so next improvement. Number of axial passes. So this is just to show you that anywhere you have axial depth of cuts, you have this option. Okay, so if I go to facing, for example, there's a new option. It's settable out here as well in the quick settings balloon, where you can be based on maximum axial depth of cut or number of passes. Okay, so I'll show this to you on my T-slot milling over here, for example. Again, it's just to show you that this exists. Maybe we're not concerned about the maximum axial depth. We just know we want to take, for example, 5 passes. Then the software does what the software does. It calculates based on your starting altitude, your end altitude, what those depths of cuts are. And just to remind you, up here it will dynamically tell you what it's ultimately taking. So if I say 10 passes, it's going to show you. Okay? So here we go. So that's available anywhere you can set an axial depth of cut. Also, just some fun facts to point out. Okay, so I showed you in the quick settings balloon that it's set that way. In multiple geometries, it will show you that as well. Okay, if you're looking in the geometry section of a toolpath, it tells you how many passes it's ultimately taking. Okay, and so on. All right, let's get rid of that. I don't remember if it's in turning yet or not. So when we get to turning tomorrow, we'll find out. Okay. All right, so let's go to the next one. Okay, so the next one has to do with spindle speeds. So let's go into here. So this is for end milling. So let's go modify the end milling. Let's look and see what our spindle speed is to start with. So here we're at 1830 RPM. And in the plunge, for example, you now have the ability to modify the spindle RPM. So let's say I want to run the RPM a little higher for the plunge. Now we can go here, generate some G code. Okay, so remember that starting. And then we have our first helical move. We're running at 2750. We're back into the standard cut. Our second helical move, back into the standard cut. Perfect. Alrighty. Next, some optimizations for breaking edges. So I see a question out there, would I be willing to make available some or all of the detailed training documents and example packages that we learned with? And the answer is most likely yes, provided your initials don't have MM in them. If they do, then it's a definite yes. So I'm going to wait to do it until the end of this week's seminar. When we release the videos next week, I will make these available for those of you who wish to download them. I just need to make sure that there's nothing in there that would violate anything as far as sharing is concerned. So sometime next week, these packages will be available. Okay. All right. So we did specific spindle rate. Let's go to breaking edges. So optimize the tool position. Here we go. So with breaking edges, we did a little bit of work on it. So let's go take a look. There's a new command in here, or a new option, I should say, in breaking edges. Called 3 position. Okay, with 3 position, it gives you the ability to configure positional settings for use with this operation. So you have your general position setting that'll be used provided no collisions are happening, lowest position or highest position. And here the software is automatically then going to pick between which driven position makes the most sense to machine the greatest amount of breaking edge possible. Okay, so you can see here the tool would collide with this, so it's using the highest possible position. So meaning it's putting the tool down deeper so that it can get with the bigger diameter in there, right? And then here it's going to use the lowest possible position, and off you go. All right, that's that improvement. Oh, you know what? I don't know that I pointed this out. I think I did. I'm trying to read these questions and talk at the same time. It's like chewing gum and walking. I said there's 3 positions you're managing. I just don't know if I pointed out where those positions are set. They're set here. So general position, your lowest and your highest. Okay? So play around with that command. I think you're going to like it. Next, another improvement to breaking edges. Min and max values. What does that mean? So when you're selecting geometries, we have made the filtering of selecting geometries even stronger. So not only does it find everything, but now you can set not just a minimal length of the flat, but a maximal length of the flat on the chamfer. Not just a minimum hole diameter, but a maximum hole diameter. Not just a minimum altitude, but a maximum altitude as well. So you now have 3 new variables, minimum there, and maximum here, to help control where it's analyzing the model to find the edges to break. Okay, there's that. All right, next we have breaking edge milling, select and deselect. So basically one of the things we wanted to do with this is this. In 715, the purpose of this improvement is to allow the selection and deselection of automatically generated geometries without them disappearing. What do I mean? So if I go here to breaking edges, we go to geometry, and I just have 2 selected right now. Some automation was done to select these things, right? But maybe I decide I don't want that one anymore. We leave behind as a yellow curve the automatic profile that was found in the background. Okay? So this way, if you wanted to put it back, you can easily select it. It doesn't disappear. You don't have to rerun the search. Okay? So it's just a way to help you organize and select, deselect things dynamically. Perfect. All right, we're nearing completion here. Next, machining feature analysis direction. Let's go to our CAM file. This is similar to what I showed you guys in drilling this morning. So a couple of things here. If we go to options and we go to CAM and we go to analyses, again, you can choose to run dynamically on the fly or not. We go back to here and now we do machine feature analysis. Okay, this way we can come in here and you can also choose a direction. For example, I want to see all features that are machinable relative to that direction. So you could also choose multiple directions. So if you're on a 5-axis mill and you're looking for machinable 2.5-axis features relative to that WCS, you can select them, leave them in the filter, and then filter. And now this has found each of the machinable features relative to that orientation. Okay, from here then, you could assign a method to it if you have a method created. Okay, if you don't have a method created, then leave it on manual machining. It's at least identified it, and it'll just walk you through it like a wizard to do the machining. Okay, that is that. All right, next one. Again, this one is having to do with manufacturing features, or as French has so lovingly called them, MFs. So, MFs. So manufacturing features, a couple of things. We've improved the manufacturing features to work with end milling and side milling, and have those features include islands as well. So if I go to end milling, I can select, and if you, I'll leave it on, doesn't matter. I can select under geometry. You see how it's highlighting the manufacturing feature, and it's seeing the island there as well. Okay, the same can be said about side milling. If I go to side milling and select the manufacturing feature, you'll see that it sees the profile as well as the island profiles in one simple selection. Okay, these are going to be really, really useful for machining manufacturing features with methods. All right, I think we're down to the last one. This one has to do with a manufacturing feature for engraving. Okay, so if I go look at this, so manufacturing features for engraving and TopSolid design, we can make a manufacturing marking. It's basically a type of an imprint on the geometry. Then in TopSolid'Cam, we can select this manufacturing feature and create an engraving milling operation from it. So we can select that manufacturing feature, right? And we can go create an engraving directly from it, or use a methodology even. Why not? So I'll drag and drop the method. Care about that. Go select the manufacturing feature and go. And there's your engraving. Okay. Perfect. Okay, so that brings us to the end of 2D milling. I imagine that most of you will be joining us for 3D milling after lunch, so I will look forward to talking to you then. I believe I see Joe has answered most, if not all, of the questions that are answerable right now. If there's any other questions at this moment, feel free to type them in. Otherwise, we will talk to you guys this afternoon. How long is a piece of string? I'm going to let you contemplate that, Mike, and you can give us a dissertation later. All right, guys. If it's your lunchtime, have a nice lunch, and we'll catch you at 1.